probably for the rest of the semester. So do your course evals. I gotta reset my brain to do this speech again. I'll keep this brief. I won't give a whole big long thing. But your course evals are very important to us. It's how the primary way that we get feedback from all of you to figure out what we should do to the course in the future to improve it for future semesters, future students. Very important to get your feedback, especially with this, where we switched from Scala to Java. And we also, I don't think I've ever talked about this in lecture, but we changed the structure of the course to something called a spiral structure. This idea that we do testing OOP data structures, testing OOP data structures, and just keep going through in cycles like that is a new approach that Paul and I are convinced is going to be, the future of how people learn and everything. But if it's not working, I want to know about that. If we should change that back to testing, OOP, data structures, and just have all 4 weeks of each topic right back to back, which is how we used to do it. And this is the first semester we've done this, and I already think that this is more natural to go in the spiral pattern instead of going from 0 to 100 in one topic and just piling it all on, and then completely shifting to a brand new topic. Getting the easy content in each category, and then kind of the medium content, and then the tougher content makes more sense to me. But if it don't make sense to you, let me know. If it does make sense to you, let me know that too. So if I just say fill out your course evals, it's going to help me and Paul and future students. Most of you don't do it. Just historically, whenever I've done that, it's about 30% response rate. So we have to bribe you. So here's our bribe. It's going to be all related to application task deadline extensions. So if we hit 60%, and by the way, the only number I get, you've probably heard this before, but just in case you haven't, the only number I get and Paul gets is the percentage of responses. How many of you have responded? It's the only information we get until final grades are due. After final grades are in, then we actually get to see what you said. And even then, it's all fully anonymous. We can't see who said what. So these are designed to protect your privacy, your anonymity, and all that. So there's only one number we get before final grades are due. So nothing you say can affect your grade because Paul and I don't even know what you said. So you have full freedom to be open and honest in these things without having it affect your grade. The only thing that can affect your grade is, as a group, how many of you submit the thing. So at 60%, we're going to extend the application task 1 deadline to this Friday at 9 a.m., which, of course, if we don't hit 60% before Friday, hopefully we hit it before Friday, and that one will matter. But if we don't hit it by Friday, that can kind of lose its potency there. 70%, we're going to move the task 1 deadline to May 5th, like before, but also the application task 2 deadline will be extended to next Friday, the last week of classes, which is effectively a week and 2-day extension. Of course, that one's supposed to be due in 2 days, so having it due next Friday instead of this Wednesday could make a big change in how you approach the assignment. 80%, task 1 and task 2 will both be due the last day of classes, and 90%, all 3 application tasks will be due the last day of classes. And Paul and I, we're not going to move a deadline past the last day of classes. After that, it's into finals week. You should be thinking about your final exams, studying for final exams. I don't think any project or homework assignment should be due during finals week, because finals week is finals week. It's 4 finals. And I'm not positive, but I feel like it's a university rule that things are due before the last day of class. Anyway, I'm not going to violate that. So we won't go beyond the last day of classes, but we'll go all the way to the max and have them all due the last day of classes. Actually, will any of you get mad if I edit this right now? Just saying this out loud kind of didn't make sense. I think at least for that last one, it's make that a little more incentivizing, and have it due at midnight. Bless you. So, not trying to reference comment 11. We didn't do the 9s as references. So if we get to 90% all three do, but this, the only change would be that application objective 3 would be due on Friday instead of Wednesday, so it would be a 2-day extension. So that 90% wasn't too incentivizing. So we'll give it a little bit more, give it that extra 3/4 of a day. Not quite 3/4 of a day. 5/8 of a day, is my math right on that? And push that all the way to midnight. That's the latest I would ever have anything due, is midnight on the last day of classes. After that, it's reading days, it's final exams. You shouldn't be thinking about homework anymore. And then I have a follow-up post on this where I'm going to update this periodically. I've updated it like 10, 15 times already. So I'll regularly check this and see what the current response rate is. You can tell I gave my spiel that I just gave in the other section, so they got their response rate up. Still pretty shy of 60, but let's see where we're at. And then I got to do quick math here. That's like 30, 35? Close enough. When we get closer to the borderlines, I'll do actual math, and I'll have to get Paul's numbers too. But we're getting there. We're getting closer to that 60. So fill out your course evals, get some incentives here. What percentage do you guys usually receive? With an incentive, it always depends on what the incentive is, how truly incentivizing it is. But usually with an incentive, 80% is usual. And if the incentive's sweet enough, I don't know if I made this 90% alluring enough. But if the 90% is valuable enough, we'll hit 90%. I don't quite know if this one's going to get there. With this one, I expect to hit 80%. I expect these deadlines to be set. But getting that extra 2 days on AO3 and a few extra hours on 1 and 2, I don't know if that'll be enough. But 80% wouldn't surprise me. Hopefully we don't hit 60 and hit it after Friday. That would be lame. But hopefully we at least get 70, so you can get something. But 80, I think, is reasonable. But y'all got to get out there and do it. Plus, you see how many empty seats there are. It can be tough to get those students filling them out. Once we get, probably on Wednesday, I do have a way to email students here, and I like to do it during lecture, so y'all can decide how aggressive I get in my wording in that one. But I can send email, and that email will go out only to students who haven't filled out the course evals. And one other thing, this does not include students who resigned. So the percentage does not even include those. So a lot of the empty seats are students who resigned the course. So they aren't part of the calculation at all. Oh, and you can see, so in 312, I don't have any incentives this semester. I just decided I'm not doing one. I pretty much know what students say about the course, and the course hasn't changed in a while. So if the feedback isn't as valuable to me, sorry, they don't get an incentive. So with no incentive, that response rate might hit 20, 25. Students really need to be bribed to fill these things out. It is what it is. I've learned to accept that, but it's something that we have to bribe you to help you, to get you to improve the courses. And some students even hold the view, none of you would hold this view, right? Some students are like, well, I want the course to get worse, so the future students have to suffer like I did. So it's an interesting dynamics. Refresh this. So there's no slides for the rest of the semester. That's why I was just updating if you were watching between lectures there. No slides. Maybe 1 or 2 of these lectures would have slides. I don't know. Maybe the TA lecture, maybe they'll prepare slides. But by default, none of them are going to have slides. I almost killed myself making slides, redoing all of my slides to get them in Java this semester, and I'm just done with them. So we have all the topics set for the rest of the semester, except the you decide. What's the resign rate? I haven't looked at the Yeah, if you want to hear some stats, I didn't calculate what the actual resign rate was this semester, but it's usually like 20%. And the number we track is we call it DFRW. Anybody who got a D and F resigned the course or withdrew from the course. So effectively anyone who didn't make it to the end. And that's the rate we really track. Each semester, that's 35-ish, roughly, the like average of the past few semesters. And it's been in the 40s before. We got it, like, it sounds weird to say this, but we got that down into the 30s, which I'm happy about, but I want to get that down further. If we can get that into the 20s, that would be fantastic, but man, it's tough to do with 116. There are just a lot of reasons students don't make it through this course, and for a large number of those students, I don't think there's much that I can do aside from just handing out A's like they're candy, which if I do that, you're all just going to fail 220, 250. I can't do that to you. But yeah, the numbers aren't great, but they have been getting better over the years. We've been getting better at this. I'm hoping Java will help that, but it looks like the failure rate's still going to be like mid-30s this semester, mid-30%. So the last lecture, this You Decide. I mentioned this before, but let's talk about it again. So I have this Piazza post, Vote on Topics, where you get to vote on what we do that last lecture this semester. I always like to do this in my courses. I'll take at least one lecture. We only have one that fits in this semester, unfortunately, but we will still have one where you get to vote on what we do. So I do say the top voted idea. We probably won't be able to do multiple ideas, but maybe. I don't know. But I do say the top voted within reason. I put that clause in there every semester. I have not once had to enforce that. I've never had to say, wow, this idea is not within reason. I'm not doing that. So take that as a challenge, if you will, if you can get something that's not within reason. But I have a pretty high tolerance of what I'll do for these. If y'all want something, I'll do it. So post your votes on here, post your suggestions, and then get your votes in. I might have to tell the TAs, TAs, don't vote on this stuff unless they're going to show up to lecture. They shouldn't get to vote. But let's go through. We can go through what's being voted on at the moment. And right now, the winner is the current leader. Maybe it changed since the last lecture, but how to declare a variable. I mean, I'll do it. It might not be interesting, but I'll do it. And we got a couple other front runners. The Industrial Revolution and its consequences. I feel like, I don't know, do you think I talk about computer science too much? I feel like I'm always talking about computer science. So doing something different would be a nice change of pace, at least. Minecraft, not getting too much traction, but a little bit. In CSE 312, one of their top voted ones, there I have 3 lectures that fit in the schedule. And one of them looks like it will be hosting a Minecraft server, so that will happen in 312 unless there's some really big change in the voting, but not quite enough to happen here. How to create an interactable user interface, which I assume means GUIs. So if this one overtook the variable declaration, it would be going through the calculator GUI, how that code works, and then maybe expanding it, however much stuff we can fit in 50 minutes. Maybe building a new GUI, changing things around, but at the very least explaining how that one is built. I'd be happy to do that. That usually does get voted up. I have covered that in the You Decide lectures in the past. How to build GUIs is always fun. CSE 250 topics would be fine. You know, I might have to brush up on some of the details of them, but that'd be fine. This one, Jesse and Paul go to each other's lectures and give a pep talk for 220, 250. We could probably do something with this. There's one just logistical issue is Paul has a 115 lecture during one of my 116 lectures, and I think it's this one, but I don't remember which one it is. But he does have a time conflict with one of my lectures. But other than that, you know, if it gets more traction in telling funny stories, you know, AI, Jackie, I tried to delete this, but it wouldn't delete. Maybe I have to mark it as resolved first. Yeah, well, I'll keep it resolved, though. TAs shouldn't be able to make suggestions. I deleted one of Jackie's before, too. I yelled at him. I'm like, you can't make suggestions on this. This is for students. If you're not going to show up to lecture, no. So don't vote on Jackie's. If you want to see runtime, make another suggestion as a student instead of as an instructor. OOP and Scala didn't get much traction. The whole course in 50 minutes, I used to do these, like instead of you vote, I used to do just straight up review lectures. And I would do that. I'd go through the whole course in 50 minutes, or maybe 2 lectures I'd take. No one seemed to really like that, though. I don't know why. I still don't know why, but I was always happy to do it. It was a fun challenge for me, but I don't think anybody else cared. But I'd be happy to do it, but I think this reflects that people don't want to see that. Leak code stuff. This one was just posted. I didn't see this one yet till just now. Just seeing Paul run Fortnite duels in lecture. Maybe get a TA to cover his 115 lecture, and then we could do that. Maybe we both go to all 5 lectures, but with only 5 votes, probably not. So yeah, so declaring a variable is, if this stays, if this is how it goes, I'll find a way to make it as interesting as I can. No guarantees. I'll try to make it interesting. The one thing I can think of with this is covering variable declaration in a whole bunch of different languages and leaving Java alone. And just kind of doing a tour of different languages. I think that's the only way I can really make this interesting. What's my favorite suggestion so far? I don't know. I didn't really think about it. I kind of like variable declaration. I ain't mad at it. Probably the GUIs one. I think going over this, I think this would be the most generally useful, and it already applied to one of your homeworks, so it would be tying that together, like how did that work, and I don't know. But it wouldn't be the most fun. Maybe Minecraft would probably be the most fun. Plus, I got to prepare something for 312 anyway. So I did get to double up my lecture prep. All right, let's see what our new number is. This doesn't tell me which section is which, so I just have to assume that the one that's going up is this section right here. So I think this is us. And we're getting up there. All right, application objective 3. Let's do this. So I should have updated this. You know what? I'm going to update this real quick. Who wants a quick get lesson? AO3. Oh, I'm lost. There it is. I guess I didn't give a lesson because I didn't say anything about it. But application task 3, despite what it says there, but that'll update in like 10 seconds once my CI, my CD goes through. Oh, and it says classes. What am I doing? Which I updated the time estimate. Like I was right here making changes, and I just completely missed those lines. All right, but anyway, what this thing is. So we're going to work with a debt calculator, and this is just like the last 2 tasks. Everything's set up, everything's released except the grader, and I'll get the grader out either tonight or tomorrow morning. So you have the starter code. Grab the starter code. And what we're doing is reading a CSV file with debt information in this format. So if we have a line like this is Paul owes Jesse $50. And all the dollar values are going to be whole numbers. We're just going to use integers for this so we don't have to mess around with doubles. So we have this CSV file with all the debt, and then 2 application objectives. And I'll be upfront with this one. This first application objective, the constructor and net gains, I think is probably too easy. It's I just wanted to get the homework out. It's the last one. I'm as exhausted as you are. I wanted to get it out. So it ended up being a little too easy, but whatever. It is what it is. And then the second application objective is probably more on target for difficulty, if not pretty difficult. It's going to be one of the tougher AOs of the whole semester to achieve, which I think that one's fine because it's the last programming task of the whole semester. So what I mean by that is if you're thinking about giving up on this homework and saying, no, man, I just can't even do it, at least get the first application objective. As long as you can understand what the description is saying, you're all capable of coding this one up. It doesn't take too much effort compared to what you've already done to get to this point. You can definitely do this one. But the second application objective, if you want to focus on other things instead of that one, I wouldn't blame you at all. So the first application objective is given all this information from the CSV file of who owes whom money. Given a person's name, give me their net profits. They call it profits, net gains. Give me their net gains. So after all the debt is settled, how much money would they make? So if Paul owes me $50 and Leo owes me $25 and I owe someone else $100, my net gains would be minus 25. Because after all the debts are settled, that's how much money I would gain, which can be a negative number. So I would gain negative $25, return that as an int, and that's it. This is intended to be the graph, a graph homework. Today and Wednesday, we're talking about weighted graphs. It'll actually be directed weighted graphs. But with this application objective, I'll be honest, you could get away with not even building a graph. If you don't even want to mess with graphs at all, you read all the data from the CSV file, store that in an instance variable, and then go through every debt that has that person's name on it, and then add it all up, and that's their net gains. You return that, write some test cases, and you got that application objective. So that's the first one. The second one, like I said, significantly more involved, more difficult. In this one, I'd be surprised if you could do this one without the graph. You probably could, but it'd be a lot more work than just using a graph. But this one is detecting cycles. So we have this find cycle method, which is going to detect if we have a cycle where there's some number of people where each person owes the next person money all the way back to the first person. So we want to be able to detect these things. So my example, if Paul owes me $50, I owe Leo $75, and Leo owes Paul $100, that means we have a cycle, Paul, Jesse to Leo, and the amount of the cycle is the minimum amount owed between any edge in that cycle, which is $50 in this case. The use case, the application of this is if we're writing a debt resolver app, debt tracker app, and we have a cycle like this, we might as well just reduce all these amounts by $50 because it's effectively the same thing. There's no point in Paul giving me $50 so I can give $75 to Leo and Leo can give $100 to Paul because Paul's $50 just comes right back around to him. So the app would subtract all these by $50 and just say, Paul doesn't owe me anything. I owe Leo $25 and Leo owes Paul $50. So it smooths things out. It just makes the debt a little more easier to track. Now, we're not actually, in this homework, we're not actually reducing the debt amounts and changing the amount people owe, just as in an attempt to control the difficulty of the task. I already think it's on the edge of difficulty. So we're not going to actually reduce the amounts, but we are going to detect the cycle, return all the people involved in the cycle in the order of the cycle, and the amount of the cycle. And there are a few caveats with this. One, the order is fixed. The cycle goes around in a certain order for the nodes, but who's the starting node of that cycle is ambiguous. It could be anyone involved in the cycle. So all three of these would be, for our example here, would be valid orderings for the people involved in the cycle. So your testing would have to accept any one of those. And again, to try to rein in the difficulty a little bit, you can assume that there's at most one cycle in the graph. So there's either no cycles, in which case you'll return null, or there's one cycle and you'll return the information for that cycle. And then in your testing, make sure you only give test cases where there's one cycle. That way we don't have to try to detect multiple cycles, which really gets confusing if you have two cycles that overlap. So if you have cycles that share edges, that can get crazy, especially if we went as far as to actually reduce the amounts of debt. How do you decide which cycle to reduce the debt of when you have shared edges? Things get really complicated if we don't have this exception, this at most one cycle. So we're going to have that at most one cycle in here. And the hint, I don't think I ever really mentioned this in lecture, and I don't think Paul has either. So I just put the hint right in the document so everybody gets the hint, is if you run breadth first search, this is another good thing we can use breadth first search for. If you run breadth first search and you ever find a case where you find an edge coming from one node to a node that's already been explored, you got yourself a cycle. Wait, is that even true? Oh, no. I might have to rethink this one a little bit. That's not even true, is it? I might be in trouble on that one. That's true in non-directed graphs. That's not true in a directed graph. Oh no. Let me get rid of the hint. This is because that was my intent in writing this, is that you would run breadth first search and do the paths with a couple extra. There are a few other things. But yeah, that's not necessarily true. I might have to nerf this. Just as I was reading right now, I'm like, wait a minute. And I never chalkboard, but I'll draw this out. If you have breadth first search starting here, there's a node here, a node here. So you'll start here, you'll discover both of these nodes. One of these will discover this node, the other one will discover it, but it's already discovered, but we don't have a cycle. It would have to be if you discover the starting node again. So I'll just have to update the hint there. If you run breadth first search and you discover the starting node, if you have an edge going to the starting node and realize that the starting node's already been discovered, because of course it's a starting node, that's what the hint's going to have to be. This is why I should always make my graders before releasing the homework, but it didn't work out that way. I'll update this. All right. Let's get on with it. Let's get on to the good stuff. All right, so what we want to do today is weighted graphs. So these are graphs where the edges are going to have weights associated with them. And we're going to use flight information, where flights are coming from and to a certain city, similar to what we did before, except now the flights are going to have 3 weights associated with them: the cost, distance, and time. And Paul has his code in here, his solution of how to do this. And you're welcome to look through it, watch his lectures, and see how he did it. I was looking at this to prep for this lecture, and even I got scared of this code and was trying to follow it, and I don't know, I got a little lost. Once he does nested type parameters and flight, which implements the cost interface with multiple type parameters, having the cost of an edge. Like, I see what he's doing and why, but I just think it's a bit much. So I'm going to try to do this a different way, and then you can wait. I use a different word than weight because we're talking about weighted graphs. But you can look at the two different ways and decide what you want to do. And I might do it different in each of the lectures. Each lecture I'm doing, I don't know, I think I'll do it just a little bit different. So here's my second way of doing this. So I want to use the same information. We have these flights, and I'm going to build these two paths, which are valid paths in the graph, Buffalo to Washington, Washington to JFK, and then this next one adds JFK to Toronto. And I'm adding up the weights of the flights as the prices of the flight. So how much is this flight going to cost if I have all these connecting flights to go from Buffalo to JFK, Buffalo to Toronto? And my expected is 346 and 746. And my intent is on Wednesday writing up better test cases, actual test cases for this. But for today, everything's going to be in a main method. I think on Wednesday we can fit test cases and add another method to this. But for now, we want to write this cost of path method. Given this information in these paths, give me the cost of those paths. So we're going to need some concept of a weighted graph instead of just a graph. Actually, before we get into that, let's do the easy thing first. Let's create this flight class. So I'm going to create a flight class which just has the, actually I think I'll let IntelliJ do a bunch of the work for me here. Private, it really didn't help me that much. Private, and I'm fine hard coding these to strings. Private string from, because the flight's always going to be the airport codes. From to, these can all be final. Final, private, final, double cost. Distance and time. I'm going to let IntelliJ make my constructor now the right way. And I'm not going to change anything about these flights. So I'm only going to do getter methods. I'm not going to do any setters. So we have a class that's just going to store these 5 values, set those 5 values in the constructor, and then get those 5 values with no other functionality. So that's our flight class. Gets rid of all those errors there, which is nice. And we're going to want our concept of a weighted graph now. Private. Oh, we can do it final. And I want to build my adjacency list. So last time our adjacency list was a hash map of, and we said this was T, a hash map of, let me stick with N so I don't have to change all those. This is what it was last time, if I can finish my sentence. Hash map of N to array list of N. But now we want some information. Bless you. Now we want some information about the actual edges in this graph. So we don't just want to know what edges exist in the graph, but we want the weights of those edges. And there's a lot of different ways to do this. You just saw Paul's way. I might as well flash up what I did in the other one. I had a edge class, and then the edge had the destination and the weight. I'm going to do things a little bit different this time. I'm going to instead have this be a map. Well, first of all, I'm going to change this to being a map. I'm going to have this be a map of the node to the price, the cost of that, or the weight of that edge. So my adjacency list is going to map nodes to all of their neighbors, but instead of just an adjacency list, these nodes are going to map to the weight of that node. And since we know about interfaces, I'm going to use the map interface, even though the actual map is going to be a hash map. I'm going to use the map interface for my variable type. So if I want to change this to a tree map at some point, I can do that. I can change these things. Well, it doesn't want me doing that. Oh, because it wants a comparator. Makes sense. Because we know what interfaces are, so I can do that. And then we're going to do the add node list. If this dot adjacency list, did I spell adjacency list wrong? Probably. If it does not contain that key, I'm going to initialize it to a new hash map now instead of array list. Add edge, add the nodes, each of one of the nodes, then go to the adjacency list. Well, first of all, adding an edge needs a weight for our weighted graph, and then our adjacency list, get the map for this key, and then it's another map, so we're going to put to weight. So we're just changing our data structure here. Instead of just here are all the neighbors, here are all the neighbors and the weight that that edge maps to. And now we're ready to build some graphs. Let's do weighted graph of string price graph equals new weighted graph. And now since my edges can only store one weight to them, I'm going to have to create a graph and then choose either cost, distance, or time which one of these I want that graph to store. So each graph can only store one piece of information. That's part of why Paul's has so much more complexity. He's storing all three of these values in a single graph and then having different ways to be able to get the cost for each one of those values. I'm going to keep things a little simpler by creating three graphs. I'm going to have one graph for each of these values. So my price graph is going to iterate over all my flights for flight, plural. Price graph dot add edge, flight dot get from, flight dot get to, flight dot get cost. So that's my money graph. And then I'm going to do a good old cut and paste here for my other graphs. And this is just something I like to do is when I'm cut and pasting a chunk of code like this, I'm going to cut and paste it, but I'm going to change some variable names. When I'm pasting, I'm going to paste it above, because then I'm going to get errors that are going to help me not make as many mistakes here. One, I get an error because I'm redeclaring this variable name. So let's change this to distance graph. And then when I change that, every place where I have to change the variable name is going to be an error because price graph doesn't exist yet. So I'm going to get errors everywhere, and the compiler literally highlights every place where I have to change things. If you do the same thing, but you paste it below, you're not going to get those errors. And now price graph gets all the edges with the cost, and then, well, let's change this first. And then price graph is going to get all these edges again, but with the distance. And the way we wrote our code with maps, that's going to overwrite all of the cost information and get just the distances here. And the distance graph isn't going to have anything in it. Now, hopefully we can see that, oh, this variable's unused, and see it that way. But if we use this variable like 3 or 4 times, and we forget to update it in one place, we're not going to have that either. So if I paste it above, I give the compiler a chance to help me out. So do it above. And we got our 3 graphs. And what we want to do now is write this cost of path method. I'm going to let IntelliJ help me out a little bit here. I'm going to create the method. That's going to give me the method header, and then I want to move this. It's common to have your main method by convention have this the last method of your class. So I'm going to move it up here. But IntelliJ created my headers for me, my method header. Now it's time to actually write this method in 8 minutes. We got this. What does the weight mean for the graph? So the weight means that each edge has a number associated with it, which is the weight of that edge. So in our case here, we're going to use the price graph. So the weight of an edge is how much that flight costs. For your homework, the weight of an edge is going to be how much money is owed. And here we're going to want one of these loops that's going to iterate over multiple values in an array list simultaneously. This is where we have to be careful with our off by 1 errors. I'm going to have I go from 0 to I less than path.size minus 1. So I have both less than and minus 1, which means this is going to go from 0 up until the second to last index in my array list. And then I plus plus. And I'm going to get both of these n's. N, which is our generic type, was going to be string in our case. Give me the string path.get of I, and my goodness, I'm missing the most basic stuff. And then path.get of I plus 1. So since we're going to have an I plus 1 here, I want to make sure that I is never the last index. It has to stop at the second to last, or else my I plus 1 is going to be an index out of bounds error. So I want to avoid that. And then we're going to do some checks. If this dot adjacency list dot contains key from, so if we don't, let's negate this. If we don't have the key from, we're going to return something that indicates this is an invalid path. 0.0 is fine for our purposes here. So if this from is not in our adjacency list, not a valid path. And then we're going to get if map of t to double. I used t in the last lecture. I don't know why I switched to n. I know why, but I shouldn't have. Let's do destinations equals this dot adjacency list dot get of from. So this is all the destinations where we can get to from the from city. And then if destinations dot contains key to return 0.0. That means there is no flight to the next city, and this is an invalid path. You can't take these flights. But if it is in there, then double flight cost equals destinations dot get to. And then I got to set up my accumulation variable so I can sum up the costs of this path. So double total cost equals 0.0. Return total cost. Total cost plus equals flight cost. So we're going through the path and summing up the weight of every edge in the path to be able to get our full cost of going from the first city to the last city. What's the cost of all of the connecting flights? And if we run this with any luck, we'll see our expected values printed to the screen here in the old-fashioned way of manual testing. And we did get our right values. And we had a few minutes to spare. Anybody have questions? Did that with just 2 classes. I think I like this way. I think this is, we have this nested data structure. Other than that, the complexity is pretty low. Pretty straightforward, I think. Where array list of edge, where edge is extended by flight. It just started losing me. Any questions on this? I'll have to go yell at Paul. Don't want to push my changes to his code. Oh, I haven't pushed in a while. Oh, I uploaded the wrong grader for Friday's lecture question. The answer was D. I uploaded the grader for E, so I have to fix that, which I might do right after this lecture question.